Good afternoon, Professor, and my dear fellow students. Today I will present my analysis plan titled Gradient Boosting for Predicting High Cost Patients in Canada's Universal Healthcare System. My goal is to use machine learning to identify patients who may incur very high healthcare costs so that early actions can reduce this cost and improve patient care. Team consists of experts from different fields. We have a lead clinical investigator from the University of Toronto, a clinical data scientist from the University of British Columbia, a project manager from Health Projects Canada, and other specialists in health economics, biostatistics, and ethics. This strong team ensures that our study is scientifically sound, clinically relevant, and ethically responsible. The reason for our study is clear. In Canada, a small group of patients, roughly 5%, uses 59% of the total healthcare funds. This high cost is a major concern, and current methods only predict high cost with about 65% accuracy. By using the gradient boosting method, we expect to achieve over 85% accuracy. This improved prediction will help healthcare providers to identify patients at risk much earlier and take preventive measures. Our study has three main goals. First, we will build and test a machine learning model to predict which patients will fall into the top 5% of healthcare spending in the coming year. Second, we will identify the most important factors that contribute to this high cost. Third, we will explore how other factors such as income influence these predictions. To carry out this study, we'll use data from Canadian Institute for Health Information. Our data comes from two sources, the National Ambulatory Care Reporting System and the Discharge Abstract Database. This data covers the period from 2016 to 2021 and includes about 1.5 million patients, including at least 75,000 high cost cases. We will carefully clean and prepare the data by removing errors and filling in missing values so that our analysis is accurate and reliable. Points or attributes are presented here based on demographics, health detail, healthcare use, and socioeconomic factor. Our analytical approach is methodical. We will split the data into training, testing, and validation sets while ensuring that the percentage of high cost cases remains consistent. In addition to the gradient boosting model, we will use logistic regression and random forest models for comparison. We will evaluate our models using several performance measures, such as the area under the receiver operating characteristic curve, AUROC, the area under the precision recall curve, AUPRC, sensitivity and specificity. To understand our model better, we will use SHAP values, which will explain the influence of each factor on the predictions. Here is our some planned results that we have been showing using bar chart. This bar chart showing high cost patients with other patients in terms of age, sex, admissions, and chronic conditions. Here is a table that is showing different model results and their sensitivity and specificity. Here is the ROC curves for model performance. So we have seen the false positive rate and the true positive rate corresponding their axes. So from this graph, like we have a visualization of different performance of different models. There is another bar chart in our analytical report which predicts of high cost patients. Basically, it is showing the top 10 predictors of high cost patients. We recognize some challenges in our study. For example, there may be missing information on outpatient or medication cost, and differences in data quality across provinces might affect our results. Although complex models like gradient boosting are very accurate, they can be difficult to explain in some terms. In simple terms, we plan to address these issues by carefully testing our models and ensuring that they perform fairly across all patient groups. Our analysis plan offers a clear and systematic approach to predicting high cost patients in Canada. By applying advanced machine learning techniques, we aim to provide valuable insights that can lead to significant cost savings and improved healthcare outcomes. As an addition, I have added an appendix, a data dictionary. This appendix provides a detailed list of all variables used in the study, including predictor variables, outcome measures, and covariates. Each variable is described with its name, description, data type, possible values or range, handling of missing values, and any transformations applied. The data is sourced from the Canadian Institute for Health Information, CAI Discharge Abstract Database, and the National Ambulatory Care Reporting System, covering 2016 to 2021 within Canada's healthcare system. Thank you all. Thank you for watching this video presentation on my analytical reporting for the course requirement. Thank you.